Good evening and welcome to the first part of my tutorial series about creating procedural generated MIDI tracks. So in this series we are creating a Python script which can create MIDI files, and I will also show you how to convert MIDI files into MP3, MP4, WAV, no, not MP4, MP4 are videos, but WAV files and anything like this. So we are starting with a really simple script which will just create a track with 20 notes. And first of all, what you need is Python, of course, and you should know some Python basics and how to install PyCharm or any other IDE. There are awesome videos you can find on YouTube. Maybe I will link some in the description. Anyway, so let's start with the tutorial. And first of all, if you are using any other IDE than PyCharm, some of the steps may be different, but all in all, I guess most steps are identical. So we already created a new project. We are deleting the content of the main file, and at first we import random because we want randomly generated tracks. Next we import the MIDUTIL library, or not exactly MIDUTIL, but from MIDUTIL we import MIDI file. So first we have to install MIDUTIL. With PyCharm this is really simple. We have just to get the cursor on the package. Yeah, I guess I wrote MIDI file wrong. Yeah, back to it. If we place our cursor on the package, there will be the option to just install it. Otherwise you can use pip install. So after we imported the MIDI file, first we will create a MIDI file object. We call it mf equals MIDI file, and MIDI file needs one argument, which is an integer. We use 1. Why we use 1 is more of a thing we should discuss in further videos, but not in our first video, because we just want one track, one channel, one kind of notes, or not one kind of notes, but not so many different notes. The script should be really simple, and we keep to the most important things, like we use some we need to declare some variables like track, which is 0. It is 0. It's also a topic for other videos and other tutorials. So in the next part of the tutorial, maybe we will use another track or other notes, but for this occasion we will use track number 0. It is still a track, it just has a number 0. Like the channel, same goes for channel. Time is another value we need. It's also 0, and duration equals 1. I will explain it in a few seconds. Volume is 100. What do we need? Tempo is also 100. And notes, the notes we are using, by the way, we are writing them in a list. If the code gets more complex, you can use a dictionary for the notes, but this is a very simple version. So track and channel I already explained a little bit, and time is when the track will start the file. It will start at the time 0, because otherwise there would be 10 seconds of quietness. We don't want 10 seconds of quietness. Duration is the time of one note. 1 beat. We can have 2 beats, 4 beats, 1.5 beats. It's a float or double, I guess. But we use 1 beat. tempo is beats per minute, it's the tempo of the track. Volume is, yeah, the volume of the track, obviously. So after we have our value built, next we need the function of our object, which is called addTempo. And yeah, with this function we add the tempo to the object. So this function needs, let me have a look, 3 arguments: track, which is track, then time and tempo. Time, tempo. So after adding the tempo, we want to add our first node. We use add node, and then let me have a look what we need. We need track, channel, pitch. First track, channel. So pitch, what is pitch? Pitch is just simply the node, and we already declared a list with 3 different nodes, and we want a randomly generated track, so we use random point choice of nodes. Okay, now after the random node we want to add the time and duration. Time, duration, and volume. As you can obviously hear, English is not my native language, and I use these tutorials as a chance for myself, for example, to improve my English skills. So I hope you are not too hard on me for that aspect. Yeah, add a node. So the track shouldn't consist of only one node. We want a track, so we use a for loop for e in range for node in range 20 nodes. No, not this one. We want to add 20 nodes. So after that, after adding the nodes, last but not least, we have to save our MIDI file, and we do this with open output.mid and wb as output. Then we have to use our object and use the function writeFile output. That should be it. We run our script, and there we have our output file. One second, I will try to play it. Yeah. As you can see, we obviously forgot something. Our parameter time is 0, so each time a node is added, it is added on the exact time. We don't want this. We want multiple times, so we add time adds 1. We start the script again, copy the output file in a folder, and oops, that's not as planned. Again. As you can see, we created a perfection of a song. Not really, but yeah. On the next videos I will try to improve the script. I already created a better script, but I can't show it. I mean, real programmers would kill me if they would see my code, so I will start a new one which I can show in public. And yeah, I hope you enjoyed the video. Feel free to leave a comment what I should add on the next video. And I wish you a great evening, great night, great dinner, whatever time it is and what is coming next. Have a nice day. I will need some sleep now. Goodbye. Hello, good evening and welcome to the second part of my tutorial series where we try to create a Python script which is able or will be able to create procedural generated audio tracks. First of all, I have to apologize for my last video, or to be more specific, I want to apologize about the quality because I expected a much better quality of the video. I guess I fixed it now. If I didn't, I apologize for this video as well. But yeah, I'm pretty sure I fixed it now. The quality should be a little bit better. And I would recommend for everyone who is watching this video as the first video of the series to look at the code I have posted in the description below, or just watch the previous video where we create the basics of the script. Now I had many thoughts how to make the script a little bit more complex, to add more variety, and first of all we should add more variety to the duration. So the frequency of the notes should be much different than only 1, 1, 1, 1, and so on. Maybe you heard the track I created in the video before. Of course, it was boring because it should be a very, very basic script. And now we don't want only 1 as a duration. The program should choose at random on which duration the note should be played next. And to make this happen, I thought about creating another Python file which we will import into the main file. And in the second file we define the function which we can call maybe make rhythm or make frequency, which should return a list of different doubles. And yeah, after we created a list of doubles, our loop will take every double and will do the function which it did before, mf_add_node, but this time it won't just use duration, it will use the part of the list. Yeah. Okay, so let's start. First we create a Python script. We name it make rhythm. I hope I pronounce it correctly. And after we created it, what we need to import is of course random, because we are using functions of the random package. And next we define a function which we also call make rhythm. This time we use lowercase letters. And we will use a 4/4 beat at first. So we don't only make a list, we will make a list, so a list which is full of lists which have a combined sum of 4, because as said I want to create a 4/4 beat. So our first argument will be a beat and the default value should be 4. Next we will create a list which we will return at the end of the function. We will name the list. Let me think a little bit. So to explain it, we have 4 pulses, 1 bar. So each list should represent one of the bars, and yeah, the doubles will represent a note or beat, how we wanna call it anyway. I mean, if we play a note, if we want to play a note, the main function should grab one of these elements of the list and should look, oh, it's 1.5, it's 0.5, and that's the duration the function will use, or the main function will use to, yeah, produce a song. So the main list we will return at the end should be called rhythm list. And we have a maximum of bars, so we define a value which I call max bars. I am thinking about this, that the max bars should also be an argument, so max bars is default 0. And yeah. Next we will create a for loop for bar in range max berry. Okay, I should rename it to bars. I missed the right I missed on the keyboard, I guess. And now we use a while loop in the for loop. The while loop should say as a condition while beat is greater than 0.1. I'm always used to use these braces, but of course in Python you don't need these braces while doing a loop. Sometimes it helps to better see the condition or to see the condition at the first view, but yeah, that's the cause I sometimes use braces even if I shouldn't. So now what we wanna have is a choice. Choice means that we need a random value, random int, and depending on the value, on the choice, the function or the loop, or no, it's a function of course, should decide whether it will add full notes, half notes, or quarter notes. So for example, if choice is greater than or less than, I guess 3 should work, we will add 0.5 2 times, and because we are doing a list and this loop is only for one bar, we will now define the second list in the loop. So the second list is bar list, and bar list should append the value of 0.5 2 times, and beat should be decreased by 1. So we shouldn't forget to reset the beat after one bar is over. So before we forget it, I will now type beat is 4. So at the next step, I will use the next condition, which is about if choice is greater equals 3, and no, I will have it simpler, 3 or choice equals 4. And if that's the case, bar list should append 0.2.5 4 times. So now to get it a little bit, to add a little bit more variety than that, we use a second rand int because that's a little bit boring. So if random rand in is smaller than 4, instead of the 0.5, we append 0.25 2 times, and else we append 0.5. Okay. Now the same goes for 0 to 5. There should be the option that we have 2 quarter nodes and a half node, and 2 quarter nodes and 2 quarter nodes. So I guess I can copy the exact same code, but the case that should occur more often is 0.25. So we will increase the value to 7, and now I see if it is, yeah, 7. 7 is the right one, I guess. And we shouldn't forget to decrease the beat by 1. So before we get to the simple case, another case I wanna show is the case of a triplet. So we think choice should equal 5 or double triplet. What I mean with that, I will define a boolean which is called double triplet, and it equals false. And if choice equals 5 or double triplet, we should add 3 ripples. Bar list append 0. No, that's right. 3 times. And of course, maybe there should double triplet would be useless if it couldn't be true in any case. So if again, if choice, if random.rand int equals Klammern 0.10 equals 3 or 0.10 equals 4, double triplet should be true, else double triplet should be false. Okay, I guess I have any case I want during this second part of the tutorial. So we can already import make rhythm as mr, and now we will create a list. And I forgot something, I guess. I forgot after we finish the beat, yeah, where beat is greater than 0.5, we will add to rhythm list the bar list. Yeah, this should work, I guess. And yeah, because I'm totally stupid, we also should return the rhythm list. Okay. So, but now we will create our rhythm list. So the beat should equal the default, and max bars should equal 30. For bar in rhythm list, for E bar, so for note in rhythm, for in bar, I mean in bar, note. And now I'm really curious, to be honest. Okay, of course, the time which goes up should also equals the note. Of course, it's not the note, it's just the rhythm, but yeah, I'm not creative enough to think of a better name at this moment. I guess when I finish this video, 30 seconds later, I know a better name. I know myself. But yeah, for this try, let's just try it. No, call it another name, because otherwise I couldn't see if it's the same one. Okay. So now after creating our first track, let's start it. As you can hear, not see, yeah, of course. Okay, I guess that's enough. As you can obviously hear, it sounds a little bit less boring than the track before, but still not good at all, just better. As you also could clearly hear, we need to add more variety on the notes, but I guess that's more a topic we should care about in the next part of the tutorial. So there's nothing else left, or nothing left than to say goodbye. Thank you for watching my video. I hope it wasn't too hard to understand what I was telling, how I was doing it. I was just creating a function which returns a list, and yeah, in the main function I created a for loop. In our next videos we also will create a function which does this multiple times, and we also create a function which will create a list of nodes. Then we will maybe create a function which will add a list which contains listlets. One list will be filled with nodes, the other one with rhythms. But yeah, that are all topics we have to care about in our next videos. Goodbye, have a nice day, night, day, dinner time, whatever time it could be. Goodbye. Good evening and welcome to the third part of our tutorial series. I guess I don't have to call the name again. You can see it in the video title because it's a long name. Now today I was thinking we should add more variety on the nodes, and we should implement 4 different kind of node lists. So I mean 2 different or 4 different kinds of node scales. At first I want to add the C major scale, and for that I will name a variable C major, and it's a list containing integers 60, 62, 64, 65, 5. After 65 we have 67, 69, 71 and 72. This should be the C major scale. Then as a second variant we want to add C minor, which has the following nodes. I don't think I have to call every node now. One mark too much, so. And yeah, let me think. Now we add F minor. I guess it is minor, which contains 65, 67, 68, 70, 72, 73, 75, 77, and last but least we have the it was B major. I hope I spell it right. It's called major or mayor, I don't know. Maybe you can help me and write in the comments how I spell it. Or how, not how I spell it, how I pronounce it. 73, I will just type the numbers. 76, 78, 80, 82. You have, as you see there, if you look at the C major, there can be 2 steps or 1/2 step or 1 step, like it's in common notes. And here I have a little mistake. It's 78. So this should work. Now we want the program to decide which of the 4 scales we are using. There are different options. For example, you can have a list which contains the 4 scales. You can also, and that's the way I choose, you can also add a dictionary which we call scale dictionary. I wanted a shortcut scale dic, but that sounds a little bit wrong, so we stay to dictionary. So like I said, you can always have a list and you don't have to declare every variable. You can also write it like this. I have a string which I call C major, and as a key, and the value is as a list. But I think it is maybe you can save some lines of code for the cost of being much more confusing. Here I have the variables, I call them C major, C minor, F minor, B major, and it's I guess it's much easier to understand this way. Of course you could comment everything. I choose it this way, you can choose it the way you want. It's always best for practice if you choose your own way and choose the way you think you are right for your own. That's how you practice it at its best, I guess. So, but we don't want, this would really be unnecessary if we first declare the lists and then as a value we choose the same list but not the variable. So it's really easy what I'm doing, so I will just skip forward. Why? So I just skipped it. Why I choose a dictionary, for example, is because you have a string attached to the list, and if you have a string, for example, you can check if it's major or minor with a function, or you can check if it is CBF. So you have just a string attached to it, which you can alter and you can do stuff with it. That's a simple case. At the moment, I don't even know an exact example, but I guess there are a few situations where it could be helpful. But also the variant, if you where you're just using a list, could also be, yeah, will also have its pros and its cons. Now the program or the loop doesn't choose nodes out of one of the four lists. First, when we enter the loop, we want to decide the program by random which of the scales it will use. So now I accidentally jumped to the other script. I want to stay in this script for now. Later we will move the stuff to a separate script and import it like we import the make rhythm. So first we have to choose the program what kind of scale we have. So we type scale is equals scale dictionary point keys and random point choice is the function. And now we should have one of the strings if I didn't miss something. Now I jumped again. Yeah, I guess I found the problem. I have to make a list out of it. Yeah, now there isn't a warning anymore. So now we have scale, which is our scale, of course, and we have to recall this one because it's not a node. It's I just call it step for. I will maybe I will find a better name for it, but that we can move on. I will call it step, and the node we are using at the moment is random. No, it's not random. Random choice, or it is. I found a better idea. It's much easier. This is a little bit too complicated and a bad one. Now I fixed it. So the node we are adding should be a random choice out of scale, and the node should only be a new node. Yeah, it should only be a new node in 7 out of 10 cases. So if random.randint 0 to 9 is greater than 3. Oh, there are 4 cases. 3 cases from 0 to 2, that are 3 cases. He should choose a new node. I could also use this variant, but yeah, I like it this way much more. Now I'm thinking, why do I get a warning? Node can be undefined. Yeah, of course it can be undefined, because it is undefined if we are not reaching this condition. So the first node has to be declared. Okay, I'm wondering if it will work now. I will delete the old file. Delete anyway 1. And at least there's no exception. I'm very curious if it will work. And yeah, you may hear. It is just one node. Why it is one node? Let me look again. It doesn't work because I'm stupid. I'm totally stupid. Of course, node is oh, okay. So I get the problem. The problem is that node is the wrong argument. Here's the argument pitch, which should be in the node. Now I have kinda broke my tongue. The node, which is a random choice, should be this argument, and this argument should be step, because this argument decides how long the duration is, and this argument decides how which node we take. So again, okay, delete anyway, and create a new track. Second try. Okay, it's only one node. Let's see what I did wrong this time. Yeah, I forgot to add the bar here as a step, not the bar. Okay, third try. Let's do it again. There we go. Oh, there was a deep one. And because I typed only 2, because I missed the button on my keyboard, there's always a very deep note between the notes. And we know we got a C minor. Kinda catchy now. Not good enough to be eligible for a soundtrack I would upload, but it gets better every video. This was the third part. In the next part we will kinda take everything here and put it into a function as well. So we have a function which creates the song, not a script. For that, I wish you a great evening, great night, great day, whatever time it is, and see you next time. Good evening and welcome to the fourth part of our tutorial series about procedural generation. And because in the next part we are gonna add a second voice like in a duet, in this part I thought about optimizing the code, doing some functions as a preparation for our fifth part. And if you didn't watch my previous video, that's no problem. I link the code in the description below, so you can simply add the code. We already made a simple script which allows us to create MIDI tracks. The script, as you can see here, the script takes one of our 4 scales and adds notes and adds a rhythm. A rhythm is a compilation of different doubles, which the doubles decide how long the duration of our sound will be, or of our note. What we didn't do and what I wanna do next is this entire script I want to make a function of it, so it's just called make MIDI tracks, so that if we run our main function we will get up to 10 or maybe even 20 MIDI tracks. We can decide how much. So to do this we are creating a function. These ones are, I guess, global values, so they don't need to be in the function except the tempo. And oh no, I copied the wrong one. Oh. Ah, there we go. Yeah, this is our tempo, it's 100. I have a really weak mind that I forgot how much our tempo was. But it was simply 100, so we put it here. I just could have copied and pasted here, but that didn't work, whatever. So now we create a function called def make MIDI. As an argument it should take a number, of course, an integer. We call it cycle with a default value of 1. So of course we have to tap. Oh, we have to create the parameter time. Maybe it's only a non-global variable is allowed, so because track, I guess, yeah, we are using the track and the channel and he doesn't mind that, but time he does mind if we use it as a global value. So next we put everything in a for loop. Like this. Make it a little bit more beautiful. This one isn't needed anymore. And max bars 60 is a little bit low. We should decide to have 70. So why did we put tempo in here? Because the song should be procedural generated, I want the tempo to be chosen by random as well. So we just give it a random int from 40 up to 180. Okay, but because it's I guess it's better to put these variables also in the loop or in the function, but not this one, of course, because they are still global variables, and this one as well. Duration, we don't need it anymore, of course, because our duration we get from the script make within. And we want much more variety, not just in the kind of notes, but in the instrument, the song or the instrument that is used for the MIDI track. And MIDI util does have about, I guess, 128 programs. Maybe more now, but I think it's yeah, it uses 7 bits, yeah, and that means it has 128 different programs, but maybe I'm wrong. I won't be too sure. I don't wanna say I'm sure about that. And to change the default instrument, we have to use another function, which is mf.add program change. Track channel time program. Yeah, we have our track, our channel, time is of course our time, and yeah, program is an integer. It's kind of a magic number, and the magic number can reach from 0, which should be a piano, to 127, which at the 120s are more like synthesizers. Will sound a little bit strange if we have a synthesizer on its own, but we will see how it will sound in the end. And of course, these are not global values anymore. We factor them. Yeah. Sometimes my German gets in my way. By the way, when I'm doing this kind of work, which is just copy, pasting, should I skip it? Because I can pause the video and I can do this. Now a comment that magically appeared, and yeah, this comment, because I can pause and play the video or record the video at any time, can pause it. I use a button on the mouse for it, and I just wanna ask if I'm writing code. I'm not good at multitasking, so I write code or I talk about it. And you can pause the video all the time, so maybe you don't need watching me writing this code. So should I skip this part, pause the recording, do the code, and then play or repeat recording the video, and you can see what I just wrote and can add it to your code? What's better? Maybe just write it down in the comments, and yeah, next time maybe I will just write the code, and if I have write much more stuff or bigger lines of code, I will just pause the recording, so you don't have to watch me the entire time just typing things in my keyboard. But back to coding. So with this program change, it should choose an instrument at random. Now let's test our new function with make, and what I forgot was I wanted to refactor these variables as well. So I did it. I want to create 20 MIDI tracks, but we will have the problem he will only give us one MIDI track. And then, yeah, that's it. He will give us only one MIDI track because he saves only as one data or one file and will overwrite it anytime. So we will have the global value of num. And we will add the num at our code. So now it should work. We click 1. And he only created one track. So yeah, because I'm stupid as hell. Let's try again. There we go. Now it created 20 MIDI tracks. I won't play all of these tracks because yeah, it's boring. They won't sound that interesting. I guess I will play 2 or 3. 1 second, let me copy it in another folder. As we hear, now he chose organ as an instrument. Yeah, no organ will play this quick, I guess, but yeah, because it's chosen by random, there are some funny and yeah, kinda interesting mixes, like this one. Okay, I see. Every MIDI soundtrack sounds the same. So as we see, I made the mistake. He has the same, yeah. I made a little mistake on that. First, what I did wrong, the program change has to be in the loop, of course. The add tempo is in the loop, okay, that's right. I guess I have to copy everything in the loop. Let me just try it. If I'm wrong and you know it better, please write it in the comments so I can, yeah, correct my mistakes in the next part of the video or the series. Let's try if it works now. Oh no, not this. I didn't want it this way. So let's try again. This is piano. This is not piano. This is not piano. Oh, this sounds kinda nice. But I don't know what it is. But it reminds me of something, of an intro of a children TV show. Okay, that's it, I guess. I think we made a huge step. Wait, let me just pause the music. Okay, now without the music, I wanna say I guess we made a huge step. Yeah, next time we will add a duet, or we will add a second voice. Maybe we will make the code that it will repeat some bars or some notes, so it will sound more like a usual because if you hear a common song, there are some themes and they are repeated in a little bit different manner. So on our next video, but I guess it will be not the next video, maybe the next video of the next video, we will add this. But on the next video we try to add a second voice which will play so one song will contain two voices. Yeah. Okay. With that said, have a nice evening, night, whatever. Have a good day. What time it is you're living. Yeah. Goodbye. See you. Good evening, welcome to the fifth part of our tutorial series about creating procedural generated Python tracks. And yeah, after we added more variety to the instruments and the notes, on this part we are gonna try to add more variety in general by adding a second voice. Before we only worked with one voice. That's the argument the object MIDI file has. It's an integer, and at the moment it has only one. And now we want to gonna change that to 2. Wow. Now it's pretty simple. We have track 0, channel 0, and time and volume. And we want to add a second voice which will get track. So we keep it simple at first. Now, while we have an object which takes 2 as an argument, we try to change let me describe it as we have now 2 cycles, or a loop with 2 turns. And we have to make the loop that the track in the channel has to be increased by 1 at the second time. So we are making another for loop. Let us call it in range 2. Now track and channel is double I. And the method will automatically add track and channel. So by changing track and channel automatically, we can add even more voices. When we wanna change it, we add the variable voices, which has a value of 2, and the variable will be in range. So for I in range voices, so yeah, the loop will have its 2 turns, and what it does automatically for each voice, it adds nodes to the track and channel, and because we already told the variables, or we already defined the variables track and channel, everything will or should happen automatically. Let's try it. So we got another 20 tracks. Let me try them out. Now I already heard one of these tracks. It sounds like that. And I really believe that something went wrong, because it only sounds like there's one voice. And now I'm in the wrong file. Okay, what is definitely wrong is that we are saving our file 2 times. We shouldn't do that. So I'm marking it and getting it 1 step back. And yeah, so now I guess it worked. Let us have a look, or let us have a, what do you say when you don't have a look, but if you have a hearing? How do you call it? I don't know. But let's try it out. As you can clearly hear, there are more tracks you have to sort out because they sound like trash, but that's normal. But the good tracks now sound better. Yeah, the piano ones sound the best, but yeah, that's it for this part. On the next part, I guess we are trying to make the second voice a more supporting one. And while doing that, we will make a second method or function, which we call make B rhythm, and then we are making B notes, which have a little bit of less variety because it sounds very chaotic, or yeah, not well structured at the moment, and we are going to fix that in the next part. Good evening, welcome to the 6th part of our tutorial series about creating procedural generated audio tracks. And yeah, after thinking a lot, I decided that I pre-write the code before starting the video. And yeah, I will explain the code during this video. You can also just copy the code I link in the description below. But for this part, I was making a lot of mistakes, a lot of dumb stuff during this video, and yeah, the video was a total mess and chaos, so I decided to re-record the video, and now I will, instead of coding myself, I will explain the code I wrote. And yeah, maybe I will find some mistakes by explaining it. We'll see. So what are we going to do today? Last part we wrote a second voice. So we have a track with 2 different voices, 2 instruments which are chosen at random, and now we want to create a more supporting voice, so that the second voice is not a second leading voice, it is a supporting voice, which is much simpler. And so again, we have the make rhythm function, and we wanted to create, depending on the max bars, we wanted to create a second function which has much in common with the first function, but it isn't that complex, doesn't have that many variations regarding the notes and the length of the notes. So what I created is a second function which takes the same arguments, but it has two lists. It creates two lists in the beginning of the function because we first create a rhythm list which is only 2 bars, and then we create a second rhythm list. This is a rhythm list we want to return at the end of the function. And what we are gonna do now, we create another loop. Here's a 4-bar in range max bars loop, and this one creates a function. This one creates a list, and we are taking the first and then the second part of the rhythm list all over again until the list is full. So because we have 2 bars, they are repeating itself in an endless loops until the track is finished. So we have the same input, max bars, like in the first function, and it's just that instead of just creating an entirely new rhythm, we want to create a more supporting rhythm. So I have 2 print functions to test the code. The second one was just to see if the length of the list is correct, but it was. And if we have a new rhythm list which has a new variety of length of notes, for example 2 quarters, 2 half, 4 quarters, and another 4 quarters, and a full note, which is 4 notes. Yes. Okay, now let's try to test it. Last but not least, what I want to say about the function is that it nearly works the same as the first function. It is nearly the same function with the differences I told before. And now I got into a random package. And if you want, I can show you. You can just pause the video now and write the code down. Or you can simply click in the description below. If you want to know how we use this code, maybe I will try it now. So we have our main function, and in the main function we should have the part where we create our rhythm list. Here it is. And now we create if voices equals 0. Rhythm list ist gleich mr make b rhythm list, and max bars is 70, and else we use the old code. Let's delete the last 20 tracks and see if it will work. Okay, now I run the wrong code. Now I ran the right code. This one doesn't sound that bad. Okay, now we heard some songs and some sounds like bad cell phones, but in my opinion they sound much better than the tracks we created in our last video. And with that I would say goodbye. Have a nice evening, night, whatever time it is. I need to think about what we're going to do next time. Have a nice evening, goodbye. Good evening, welcome to the, let me think, it should be the 7th part of our tutorial series about creating procedural generated audio tracks with Python. So we are at the 7th part, and what we want to do now is we want to create another file. In this part of the tutorial we won't do any new we won't produce any new tracks, but we will make the entire code more compact and better to create expansions for the code to create better tracks and to improve the code. Because at the moment we have the file make rhythm, which makes a list of rhythm, and now we want to create a new list. And we want to create a new file, and the file takes a rhythm list and creates an identical list with nodes in it. And yes, for this one we have to rename, or we have to rename our nodes and make dictionaries out of it. So what we are doing is the node is now chosen in our rhythm list. It's generated in our rhythm list, but not in our rhythm list, I'm sorry, in our main function. But we want to create another function which creates a list of nodes, and for that we will create a new file first. But before we create a new file, so not first, we will make dictionaries out of these lists. So for example, the C major one, we will create this dictionary, and we are using characters as keys, of course a C. So we will do this on the other nodes, but I will pause the video. I will do it by myself. 1 second. And as always, I did something wrong. We only need one dictionary. So I will redo the entire code I just wrote. And instead of making 4 separate dictionaries, we only make one dictionary, which will look like. So it should look like this one. And now we will change the lists of string lists. So they are number lists or integer lists, but we want string lists like this one. So what I'm doing is I'm deleting the list. I'm not deleting the list, but I'm changing the values so that a random choice of our node is chosen. And what the main function does, or the make MIDI function does, is just choosing by random one of these values, and using it as a key in node directionary and getting the integer value. So I will do this for the other 3 ones. Now we have a C minor. Let's do this one live. So we have a 65, which is F. We have 67, which is G. We have 68, which is Gis. 70 should be B. 72 is C2. C2 is just one higher. 73 is Cis2. And 75 is this 2. And 77 we have F2. Now we are deleting this one, and yes. Okay, finally we are finished. Now let's move on. Of course, these ones are not needed in this function, but in the file we are creating now. It is a new file, so we are creating new Python file. We call it make nodes. We have a function. And we make a list we wanna return at the end, so we call it red list. And for bar in rhythm list, for beat in bar, so now it is already time to copy these files, or not these files, but these lists, as global variables in our new function, in our new file. And now what we are gonna do, we want to decide by random which one of these we are taking. So we are creating, you maybe guessed it, a new dictionary, or we can make it simple and copy our old dictionary, which makes much more sense. And lazy as we are, we have already written scale is random choice of the values. So we also copy that. We are not allowed to forget. We have to import random, and we have to import make rhythm. Now the second part is pretty easy. We want to make a new list, and we don't need to decide in which bar or beat the node is written, because the algorithm just sees, oh, I have this beat and I will give it this node. But we still want to make it more structured, so we create the red list as another list. So what we're gonna do, we will use a default word, which is, I never tried this before, to be honest, but this also should work as, so we choose the function as a default. And now we are in the beat, so we create temp list which we create after he has this bar. And yeah, we want a random choice from scale. And red list should contain this list. Now look at that. That seems kinda right for me. Now we have a 3-dimensional list we wanna return, and the first part is our rhythm list, and the second list is red list. And later we will add a third list, which will be the volume of each node, but this is something we're gonna do for later. Now we should first test the function. Does it work? Just make nodes. We should choose our bars for our rhythm, because the default is 0 and we don't want 0 bars. And there's a first mistake. Scale dictionary is not defined. Okay, it can't work because we are not starting our second file, we are starting our main file. And yeah, this is our main file. Of course, make rhythm. We don't need this test print, but we wanna print a new list. So we don't wanna prompt it, we want to print it. Okay, we have, let me have a look. We have 1, 2, 3, 4, 5, 8 beats, and if I am correct, this should be 8 notes, and yeah, 8 notes. This has 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh my god, this is too much to handle for my little brain. Okay, let's start again. 5, 10. If you're gonna laugh at me, do it, I deserve it. 16. So 16, and the length of this list is 4, 8, 12, not 16. But maybe I am just bad at counting, and I am bad at looking, because this is the right list we have to count, and it is 4, 4, 8, 12, 16. Yeah, that should be enough for now as a test. So we have our new function. We're gonna import it. And instead of rhythm lists, we are now creating note lists. So where here I will n point make nodes make mr point make rhythm max bar 70. And of course this one is bwism, because we have one bwism list. So now we have node lists. So what we are gonna do next, we have our node list, and yeah, we wanna use this node list. What we are gonna do now is we have our node list, and let's use the rhythm as default. I accidentally got again in whatever. It was a random package, I guess. So again, we are now in our main function. So we are in node list 1. And we want to enumerate our node list. This one, we don't need this anymore. We need another loop, which is our bar, or our which loops through our bar. Now I have something on my tongue, which loops through our bar. I hope I got it right. So let's rename bar to step, just because I used this one before. So let's move this one back. And our node is not a random choice, but it is from our node dictionary. We have our node list, 1 E E E double E. Now we should have our node we wanna have. and I'm wondering why this is at a random. Oh, maybe because there can be a, I don't know, there can be a break, but from now we don't use breaks anymore. In our next video we will use breaks. And let's delete them. We are nearly finished. Let me think, what is missing? Okay, I don't care. Let's just try it. Okay, please don't let it be red. It is red. Oh no. Okay, where is our mistake? Okay, CE2. Oh, this is pretty simple. We don't have CE2. Let's try again. Oh, this looks not so bad. But does it sound bad? Let's try. Oh, this is my favorite of these. This one is not so bad in my opinion. Okay, this was the 7th part. On the next part we are looking at how to add volume to the list. We are even expanding the list we already created, and yeah, until that, I wish you a good evening, good night. Where I live it is now late evening, maybe even night. Goodbye and have fun with coding.